One of my many hobbies is ham radio, which is a hobby where enthusiasts use commercial or home-built radios to contact people all over the world. A recent interest of mine in this field is in Morse code, also referred to as continuous wave. Morse code is a method of modulation that uses a combination of short and long signals to convey messages. In the interface that allows the user to control what gets sent out, switches are used. The most simple and straightforward example of switches like this is a straight key, which is simply a switch that completes a circuit, which keys the transmitter, like this, to send out a signal. Here the radio operator has complete manual control over sending the code, including how long the dots and dashes are. I will demonstrate how this is used. As you can see from the movement of the hand needed to use this device, it practically screams carpal tunnel syndrome. Prolonged usage of a straight key is quite painful, and I think the hours I spend typing in front of a screen is enough strain on my body. Also, if the timings of the dots and dashes are off, it might be hard for someone on the other end to copy my code. Though being able to send code well on a straight key is rewarding, there must be a better solution out there, and there is. Enter the Iambic paddle. This device consists of two paddles, or switches, that trigger the transmitter for a dot or a dash. The left paddle is a dot if you press it once, and multiple dots if you hold it down. Same applies for the other paddle, and it sends one dash if you press it once, and if you repeatedly press it down, it sends repeated dashes. The cool thing about this is you can press both down for a repeating dot dash or a dash dot, depending on which one you press first, like this. Like that. For an Iambic paddle to be used, a device called a keyer needs to accompany it. This is an example of a keyer. It is a device that recognizes the switch actuation in an Iambic paddle and translates that into dots or dashes of set length. As you can see, this only consists of two switches, and there needs to be a separate device that seems like a straight key to a transmitter, but sends out a pre-calculated dot or dash, depending on which switch you press down on the Iambic paddle. Luckily, our Flex radio here already has a keyer built in, so we don't need to worry about using this keyer. Now to the main focus of the video. I would like to make my own Iambic paddle that uses capacitive touch sensors using what I learned in EE16A. There are many benefits to using this design, such as mechanical durability. There are no moving parts in the actuation of capacitive touch sensors. Here's a brief overview of how touch sensors work. Here we will use some circuitry that was a part of our lab that we did in our EE16A class. If you look at the circuit simulation, you can see that the waveform changes as the capacitance changes. In an Arduino, a similar mechanism is used. The time it takes to charge the capacitor in the circuit is measured by an internal timer using CPU cycles. A change in this time, the charging time that is, would result in the actuation of the sensor. Here's the completed circuit. It uses the Arduino Nano programmed with the CapSense library to sense the change in capacitance using the techniques that were just mentioned. I will put the links in the description for the schematic and the Arduino code, as well as the different resources you can use to understand this circuit. When a user touches one of the contacts on the bottom, the Arduino detects the touch on the left or right contacts and sends out a signal on its corresponding digital pins, which are each connected to the base of a 2N3904 transistor. The emitters are connected to the ground, and the collectors are connected to the two leads of the 3.5mm jack. I won't get into how transistors work here, but they are essentially acting like switches that can handle higher currents that the Arduino can't handle, since this device may be plugged into various radios. The transistors then short the right channel pin or the left channel pin with the center common pin on the 3.5mm jack, depending on which contact was pressed, to key the keyer, essentially telling it which signal to send out. Let's give it a try.